guys, welcome to Math1141 videos. So this time I will talk about Math1141 Algebra Chapter 3. Now, question 87. Now, let's look at this question. Prove by induction that sum of 1 squared minus 3 squared plus 5 squared minus 7 squared plus 9 squared minus 11 squared plus blah 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 is negative 8n squared if k equals to 2n and 8n squared plus 8n plus 1 if k equals to 2n plus 1. So basically we need to do this question by induction, right? So we need to follow step of induction. Now let's look at this question more clear. So what does this question talking about? So if n equals to 2n, the sum of this series will be negative 8n squared. If n equals to 2n plus 1, the sum of this series will be 8n squared plus 8n plus 1, right? So, which means we have to analyze it in two cases. So, we got case 1, which is case 1, which is k equals to 2n, right? Which means it will be 1 squared minus 3 squared, or 1 squared minus 3 squared plus 5 squared minus 7 squared, or 1 squared minus 3 squared plus 5 squared minus 7 squared plus 9 squared minus 11 squared. So always be minus at the end of this series, right? So which means the last term of this series will be 2k plus 1 squared, right? Because if n equals to 1, k will be 2, and this term will be 2k minus 1. So if n equals to 1, so k will be 2. So it will mean second term. If it is second term, so what's the value of second term? It will be 2k minus 1. So 2 multiplied by 2 minus 1, 3 squared, right? Now we need to analyze case 2. K equals to 2n plus 1, right? So just same strategy here. So it will be 1 squared minus 3 squared plus 5 squared, or 1 squared minus 3 squared plus 5 squared minus 7 squared plus 9 squared, or 1 squared minus 3 squared plus 5 squared minus 7 squared plus 9 squared minus 11 squared and plus 13 squared, right? So it will always be positive. It will always be pass at the end of this series, right? So same thing, like, so what will be the last term of this series? It will be 2k minus 1 squared. In this case is 2n plus 1. In this case is 2n, right? Now let's start doing this question. So we need to look at case 1 first, and then we look at case 2. So case 1, right? We need to prove it is true for n equals to 1, which means k equals 2, which means last term will be 2 multiplied by 2 is 4, 4 minus 1 is 3, so it will be 3 squared, right? And so left hand side will be 1 squared minus 3 squared, which is negative 8, right? And right hand side will be negative 8 multiplied by 1 squared, will be negative 8 too. So left hand side will be right hand side. So true for n equals to 1, right? So what's the next step? Obviously we need to assume n is true for n equals to k. So assume it is true for n equals to k. Right? No, I mean n equals to n, because we got k here, so we need to choose another variables. So we choose n, which means k equals to 2n plus 1. K will be 2n, sorry, k is 1, 2n. So k will be 2n, and last term will be 2 multiplied by 2m, right? And then minus 1 squared, which will be 4m minus 1 squared, right? So left hand side will be 1 squared minus 3 squared plus 5 squared minus 7 squared minus 4m minus 1 squared will equal to minus 8, right? N squared, what's n? N is m, so it's m squared. It's right hand side, right? Now we make an assumption. We make n equals to n. Now we need to prove it is true for n equals to n plus 1. Alright, so prove it is true for n equals to n plus 1, which means k will be twice n plus 1, right? So which means last term will be twice k, so it's twice 2m plus 1 minus 1 squared, right? So twice k, 2 times k, where k is 2m plus 1, twice k minus 1, so minus 1 squared, which is 4m plus 4 minus 1 squared, which is 4m plus 3 squared, right? So you can see why I need to write down what the last term is, which will make this process much easier, right? So now we need to prove this. We have left hand side, which is 1 squared minus 3 squared plus 5 squared minus 7 plus minus 4m minus 1 squared, right? And plus next term, the next term will be this term plus 2, right? The next term will be previous term plus 2 and squared, which is 4m plus 1 squared, and then plus 2 again, which is last term, 4m plus 3 squared, right? Makes sense. 4m minus 1, 4m plus 1, 4m plus 3, right? And the minus plus minus. Right. And from previous assumption, we know 1 minus 3 squared plus 5 squared until minus 4m plus 1 squared will be negative 8m squared. So it will be negative 8m squared plus 4m plus 1 squared minus 4m plus 3 squared, right? And the rest is quite easy. You just expand it out and then make sure it will go back to minus 8m minus 1 and big square, and then you finish this question. So if you know how to do it, you can stop here. If you want to see the rest, you can just stay online. So, which is plus 16m squared plus 8m plus 1 minus 16m squared plus 24m and plus 9 16m squared, 16m squared cancel out. 8m, we got 16m left. 1, we got 8 left. So what we got, which is negative 8m squared minus 16m minus 8. Right? So we just collect the same term. We can take out the 8. 2m plus 1. Right? And we can, from high school maths, we know this is perfect square m plus 1 square. So we got negative 8 m plus 1 square. So equals to right hand side. Right? So it is true for equals to m plus 1. Then you can write a conclusion. So which is it is true for n equals to 1, n equals 2, n equals to 1 equals 2 equals 3, and k. No, I should write. Now you can write the conclusion, right? So we can say, so it is true for n equals to 1. Assume it is true for n equals 2 and equals 3. And a k, and we prove an m. Sorry, just like to write k. So it's true. We assume it's true for n equals 2, n equals 3, n equals 4, and until n equals to n, and we proved it is true for n equals to. It is true for n equals to m plus 1. So by mathematical induction, it is true for n equals to it is true for n equals to positive integer, which will make case 1 be true. Right? So you guys know how to write it, so I don't write it. You just write. So by mathematical induction, it is true for n is positive integer to satisfy case 1. Right? And it looks like we finished the case 1. Right? Now we need to do the case 2. And case 2 is just same strategy here. Right? So alright, so we successfully prove the case 1. Now obviously next thing to do is prove the case 2. Right? So the way to prove the case 2 is exactly the same as we do for the case 1. Instead of using k equals 2m, we use k equals to 2m plus 1. Right? So for the case 2, right? For the case 2, we need to prove true for n equals to 1. Right? So which k will be 3, which means last term will be 2 multiplied by 3 minus 1 is 5, so 5 squared. Right? 2 multiplied by 3 minus 1, 5 squared. Good enough. Left hand side will be just substituted into the left hand side. 1 squared minus 3 squared plus 5 squared, which is 70. Right? And right hand side, which is substituted n equals 1 into this part. We got 8 plus 8 plus plus 1 equals 17. So left hand side equal right hand side. So true for n equals to 1. Right? Just roughly write it. So you guys will know, you guys should know how to write the n. Right? Now we prove it is true for n equals to 1. We still need to make assumption it is true for n equals to n. Right? So assume it is true for n equals to n. Right? So which k will be 2n plus 1. Right? So last term will be last term will be 2k minus 1 squared, which is 2m plus 1 squared minus 1 squared, which is 4m plus 1. Right, and then we'll write down left hand side, write down right hand side, and equal them, and then prove n equals to m plus 1 is true. Left hand side, right hand side. Right? Now we can say prove it is true. Sorry. N equals to n plus 1. Right? And write down what the k is. Right? So what's our last term will be? The last term will be what? 2k minus 1 squared, right? So 2k minus 1 squared, 4m plus 5 squared. Right? Now we just prove it, and then basically we're going to finish question. So left hand side will be 1 squared minus 3 squared plus 5 squared minus blah 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 plus 4m plus 1 squared minus 4m plus 3 squared plus 4m plus 5 squared. So we're going to reach the last term, which is 4m plus 5. Right, makes sense, because every time the next number will always be have different than makes sense, because every numbers, like the difference between two numbers will be 2, 1, 3, 5. So 4m plus 1, 4m plus 3, 4m plus 5 makes sense, right? We know from the assumption this part we're going to be 8m squared plus 8m plus 1, and we'll just copy down this part. Right, and expand it. And now, and then next we need to write the right hand side, and then compare left and right and make sure they are equal, and then we're going to prove it. out, we got 16 m left, so 25 cancel out, we got 16 left, and pass it back, we got 8m squared plus 24m plus 17. Alright, this is very easy algebra, so I think you guys should all know it from high school maths, right? From high school maths, right? So right hand side equal to 8 m plus 1 squared plus 8 m plus 1 plus 1, and just do the same thing with standouts, and we'll got exactly same solution as we do from above. So left hand side equals to right hand side. So it is true for n equals to m plus 1. And then we write in conclusion, it is true for n equals to 1, and we assume it is true for n equals to 2, 3, 4, 5, and 2k. And then we prove it is true for n equals to m plus 1. So by mathematical induction, it is true for n is positive integer, where it is true for case 2, and then it's true for case 1, it's true for case 2, so we prove the question. Okay, I think it's pretty much it, right? This question is pretty much long question, but it's not really hard. It just basic logic is just follow mathematical induction, and then like the hard part or tricky part is I think you guys need to write k equals to 1 and last term, and then you can see you can have much clearer views of what's going on here. Okay, so beside that, I think it's not that hard. So thanks for watching. I hope this helps.